We want to determine if the series summation from 1 to infinity of 3n squared plus 4n plus 5 divided by 16n to the fourth plus 9n cubed plus 12n plus 14 converges or diverges. We're going to use the limit comparison test, and we'll abbreviate that by LCT. Now here's a brief description of the limit comparison test. We have two series which we'll call the summation a sub n and the summation of b sub n. The only restriction is that these terms an and bn for all n should be positive. And if the limit as n goes to infinity of an over bn is equal to L, with L positive, so it has to be greater than 0, and finite, then the two series either both converge or they both diverge. So the conclusion is either the series an and bn both converge, or the series an and bn both diverge. So in other words, we can't have an series converging while bn series diverging, and vice versa. So let's go back to our series. The series was the summation n equals 1 to infinity of 3n squared plus 4n plus 5 divided by 16n to the fourth plus 9n cubed plus 12n plus 14. We're going to call this our an series, and since this series starts at 1, we'll call it the summation from 1 to infinity of a sub n. That's how we should always make the selection. The unknown series, the one we're trying to figure out if it converges or diverges, we'll call it a sub n. And now we have to decide what our b sub n series is, and the choice should be made based on two criteria. The first one, it should be a known series. We should know if it converges or diverges. And the second, that the limit of as n goes to infinity of an over bn should be finite and positive. So let's look at the nth term of our series here. 3n squared plus 4n plus 5 divided by 16n to the fourth plus 9n cubed plus 12n plus 14. This series will help us decide what the selection for the bn series should be. Let d be the highest power of n in the denominator, and since we have 16n to the fourth in the denominator, the highest power of n in the denominator is 4. Let n be the highest power of n in the numerator. Since we have the 3n squared there, n is equal to 2, and now subtract n from d to get us 2. The difference in the highest power of n in the denominator minus the numerator is equal to 2, and that is the determining factor in the selection of our bn series. It should be the simplest series where the difference in the highest power of n, denominator minus numerator, is 2, and clearly such choice should be the series from 1 to infinity of 1 over n squared. Now let's evaluate the limit. So let's look at the limit as n goes to infinity of an over bn, and it becomes the limit as n goes to infinity 3n squared plus 4n plus 5 divided by 16n to the fourth plus 9n cubed plus 12n plus 14, and divided by 1 divided by n squared. Now, when we simplify this, of course, by basic algebra, this has the effect of having the numerator here multiplied by n squared, and this becomes the limit as n goes to infinity. 3n to the fourth plus 4n cubed plus 5n squared divided by 16n to the fourth plus 9n cubed plus 12n plus 14. And now to evaluate this limit, we notice that both numerator and denominator have the same highest power of n, which is n to the fourth. And so the limit will be the ratio of the coefficients of those highest powers, which is 3/16. And this is our L. It is clearly finite and positive. Therefore, the two series, the summation n equals 1 to infinity of 3n squared plus 4n plus 5 divided by 16n to the fourth plus 9n cubed plus 12n plus 14, and the series n equals 1 to infinity 1 over n squared, both converge or both diverge. But this series we recognize as a p-series with p equal to 2, which is greater than 1, and therefore this series converges. And now we can make the conclusion that the series we were looking at also converges, and this is by the limit comparison test. For more videos, visit www.mathprepvideos.com.